Hello, my name is Janet Chicaiza. I am from Ecuador. Today I talk about an ontology of personal learning environments in the development of thesis project. This presentation has three parts. Firstly, I start speaking about background and motivations. What's the problem? The thesis is a final step in academic formation of students, but there are some difficulties associated with its completion. Thesis development requires important research work. Internet allows students to access relevant and large amounts of information. However, exposure to too much information can produce intoxication on students. To find and process the appropriate information can take a long time, which generates errors and delays in delivery times. Therefore, there is a need to organize such information and technological resources. Nowadays, semantic web is being used to complete this goal. In this way, students use the web in order to easily find free and relevant material. Students can interact with others in order to create knowledge networks. We address this problem with an approach based on two ways. Firstly, we use a personal learning environment which a resource or platform with students would interact with others and manage their information. Secondly, we propose the use of ontological model to organize this information. Learning occurs when the strategies and appropriate tools are harmonically combined according to the cognitive level required for the learner. Mainly, a PLE is a set of service, tools, and connections used to reach a learning goal. By means of a PLE, students can manage information, generate content, and connect with others, thus improve their thesis project. It's the result of three basic cognitive processes: reading, reflection, and sharing. In this slide, some difference between web-based on document and web-based on data are presented. Semantic web, which is an evolution of the document-based web. In the context of the web of data, which is oriented towards an ecosystem of linked data, ontologies are being used as a model for the organization of knowledge. In this way, machines can process automatically the content that is described by this mode of representation. Ontologies are become a fundamental part of the semantic web, which is an evolution of the present web. Ontologies guarantee that computers can access structured collections of information and sets of inference rules that can be used to create new knowledge. To model and manage curricular resources with the goal of facilitate the access and retrieval of curricular information, and from the institutional point of view, to be able to determine curricular complaints and use in other processes. Ontologies are used in e-learning contexts to describe learning domains from several perspectives, enable the description and retrieval of learning content, to describe students' data of profiles with the aim of producing evaluation, service, and personalization, and to describe a learning service through shared vocabularies that facilitate interoperability and data exchange among different educational systems or e-learning systems. In this domain, is PLE, it was not possible to find a specific model that described the PLE used for developing a degree or postgraduate thesis student. The ontology pled for a thesis was created according to the most recognized methodologies used to accomplish this goal. Methodology and the practical guides proposed by Noy and McGinnis. The idea in unifying these two approaches was to start a formal and agile process for the ontology creation. This figure shows the activities defined by each methodology and the final process. The rough definition of the creation process, called agile methodology, was due to the fact that the team participating in this proposal shared roles as ontological engineering as an expert in the domain of interest. This helped in the development of a more agile process in creating a formal and consensual ontological model. The ontology has been designed in order to model the components of a PLE for the development of a thesis project. Depending on the requirements defined in the specification stage, the most relevant terms of the domain are identified. From this catalog, we identify existing ontologies and vocabularies to describe the most relevant terms of the domain. Through the popular service linked open vocabularies, some approaches to describe the general terms of the ontology were found, such as thesis, person, resource, document, among others. These tables list the main ontological resources and vocabularies that were selected according to their popularity and coherence with the domain. Each term identified in the previous stage now is described in detail. The explicit specification of each term is the key to eliminate problems of meaning and construct the conceptual model of the ontology. This table shows a subset of terms that are explicitly defined. Figure illustrates the case of the deliverable concept, in which the top-down approach was used, which begins with the definition of the general concept and then its specializations are identified. In this case, document, dataset, and product. Links object properties among concepts are identified in this step. Figure shows a high-level view of the binary relation diagram. Here, the main classes of the domain and how they are connected can be distinguished. Based on the semantic expressed by the ontological model, inference rules have been designed. In this picture, a rule for a recommendation of experts is described. In the last step, the computable model using Protege was created. Protege is a free open-source platform and well-known tool in the community. Finally, Pellet Reasoner was used to check consistencies of the ontology. Both the final version as well as its intermediate versions were syntactically validated. In addition, through the creation of a set of individuals, authors verified the completeness of the ontology for describing real thesis project. To understand the potential use of the ontology, we illustrate one use case. Figure shows the generation of a new facts of new knowledge thanks to the rules of inference defined during the development of the ontology. In this case, the rule helps to make a recommendation for experts following the logic described in previous slide. Student A is developing thesis project P about subject or concept C. A student has tutor R and tutor R knows expert X. As tutor R and expert X know about topic C, the same topic that is related to thesis project P. Then, a rule-based inference engine will generate a recommendation. Expert X knows them in C and could help with the development of a student S thesis. Finally, I present the conclusion. A thesis project has phases and generates deliverables at the end of each stage. Gaining control of these deliverables coupled with the optimal use of technologies and strategies will improve the delivery times for thesis completion. The presented ontology can help to control both aspects. As a future work, a wiki semantic is being personalized so students and tutors can easily fit the ontology. Subsequently, through semantic technologies, this ensures the generation of new knowledge and the creation of interesting representations for understanding the state of progress of the project. Thanks.